Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you've all had a nice Christmas/winter/New Year break. Yeah, mine has been pretty good. I didn't really mean to take such a long break from streaming. It just, I don't know, there was always something going on, so I never really had a chance. But yeah, I should be back to normal now, so. But I think we'll just continue with the grass system that we were working on before, because my next tutorial after my HLSL shader tutorial will be about this grass system, so I guess I should polish it up. Okay, so it's all... I'm trying to remember where we stopped. Okay, so why is it? I remember, yeah, we had this issue where it was black. Okay. And it's because something was... Oh yeah, it was that weird light bug. So yeah, I just need to like disable a light. Maybe this is something else. Oh yeah, those are baked lights, so that's not going to do anything. Yeah. Okay. Yeah, there's a weird bug in 2020.3 with shadows and additional lights. Yeah, see, so now I created that and then deleted it, and now it works with this original spotlight. And it's like Unity doesn't really assign the shadows correctly to certain shaders, and I haven't really been able to figure out why it happens, because you can see that the shadows, like, they worked fine on the ground texture, but not on the grass, so it's a little strange. But anyway, maybe I'll see if I can figure out that bug a little bit more later, but I don't think that's what we'll work on today. Let me open up my to-do list. I'm not sure what it's on right now. Okay. Okay, so we did finish the wind. Okay, so yeah, we have... There's a bunch of little experiments I want to try. I think this was for something else, but I guess I'll leave that. Okay, so what other... So right now we just have instance lit grass. So what other... Right, yeah, this is instance lit with tessellation, I think. Yeah, okay. So that we don't have like a non-tessellated version, but... Alright, let's see. So we want grass, I guess, I don't know, shader, variance. Well, variance isn't, that's already a term, so I don't know, grass, shader, types. So we have instance lit. I want to try like a hybrid instance lit where, okay, I guess I should explain what this means. Instance lit is the current version where we just calculate lighting once for each grass texture. So you can kind of tell, let me find a real-time light here. Let's see the, what's going on there? Okay, well, it seems to be working right, but I'm not sure why these blades are staying orange. Is there a baked light there too? So just another instance of that weird lighting bug. Yeah, they're not orange anymore. Okay, well, there seems to be like a phantom light right there. But it's weird because... Alright, well, I don't really want to spend time on it right now, but it is strange because the grass is still being lit by the red light, but not the ground, even though they both like come from the same mesh. So I don't... But anyway, so you can kind of see these are instance lit because when you move the light, basically the entire blade is orange or not, instead of it, you know, like here. There's no like orange gradient across the grass texture. So that's what instance lit is, and so I wanted to try like a hybrid where the like the lighting is instance lit, but then we still do, I don't know, like a screen space ambient occlusion per fragment, and that way you could still get ambient occlusion shadows. Might be kind of cool. Oh yeah. So the hybrid instance with a fragment. Green space. And I could do like a vertex lit where we calculate lighting for each corner of the grass. I guess we might as well. And then the fragment lit, which is where we calculate lighting for every pixel on the grass. So the cool thing about the fragment lit is because that's the only one that can have like specular highlights. So because it doesn't really make sense for the entire blade to have specular highlights. This is gonna annoy me. Try to fix the weird lighting bug. Okay, and so that's for the grass shader. Then for the ground, so basically the system uses like a hidden camera to raycast down to try to find where terrain is that the grass should grow on. And so every type of terrain that you want to grow grass on, you have to have a specific shader for that. So this current one grows grass based on a texture, like a control texture. Let me see. Yeah, so if I change the density map to like a stripe texture. I don't see any stripes on that one. We can use this noise. So yeah, you can see that the grass has a little bit more, like it's not as even because we're using this noise texture. It's not, I thought I had one that had like, okay, so here's like a gradient. I guess you, oh, the tiling is making it difficult to tell. Do I really? I thought I had like stripes. But anyway, so yeah, I can turn it black and then nothing will grow. But obviously we don't want that. But anyway, so there's this version, and then I'd like to make a version that does a density based on like vertex colors, so that way it would be compatible with Polybrush, And then of course, Unity terrain is probably the most complicated. So that we'd have to try to like say that grass only grows on a certain terrain layer. And then we'd have to read the terrain layer data. Yeah, so we kind of have to re-implement the Unity terrain shader, which will be a process, but anyway, so let's see. I guess I'll call this sprouting shaders. Okay, so I guess we'll just have properties, and then we have the texture, vertex colors, and I'll need to make sure this is compatible with polybrush. Gosh. And Unity terrain. So basically I need to make sure that every type here is also compatible with every grass shader type. So yeah, that's going to be... well, it's not really too difficult. Basically, it's just depending on what grass shader type, it sends different data about, or it stores different data about the grass blades. So okay. So let's make sure. Okay, so this is like, yeah, so right now I'm going to use tessellation, but I do have, excuse me, something here to try to generate the grass meshes instead of using tessellation. Because right now, basically, we just generate the 4 corner vertices and then tessellate that. But you could probably get better performance. Well, I guess that's what I want to see. If say I generated a grass card with like 6 vertices, and then we want to have to tessellate it. But the only thing about that is I have to find some way to generate different number of vertices based on the LOD level of the grass blade. So every grass sprout won't have the same number of vertices, which can get a little difficult. But yeah, I want to try to see if I can get that to work. Okay. Oh yeah, and then this was, so right now if I move the terrain, oh, they won't let me because it's static, but okay, yeah, it won't let me, but I guess I can do it outside of play mode. So if I move this, you can see in the game view the grass kind of like jumps around, and that's because the properties of the grass are determined by its position in world space. So I thought it might be nice to have a way to determine the properties based on I don't know, like some data that's inside the terrain texture instead, like the color or something. Yeah, so that way you could have grass that's on a moving model that doesn't have it jump around. Oh yeah, and here I wanted to have different LOD radiuses or radii depending on the, or I think right now the radius for each LOD level is constant, so I wanted you to be able to set that independently. Okay, and then here, URP has a depth priming pass that they added in 2021.2, I think. So I was going to see if I could use that instead of the one that I wrote for myself. And then this last thing is, okay, so in the sprouting shader, if I can find here. Okay, no, that's not it. Okay, yeah, so here, so So the sprouting textures use like a normal fragment shader, but they don't actually like output any meaningful data to the texture. But you can't run a fragment shader without a texture. So I was thinking like, can I output all the data I need into various textures as if this was like what's it called? A deferred rendering where you output to multiple textures at once. So I might try that, but as I think about it, I don't really think it'll work that well because we skip over positions. Like some fragments don't write to the texture because of LOD levels. So there'd be like empty spots in the texture. I guess it might still be faster. I don't know. That's kind of what I wanted to see, but anyway. Okay, I see I haven't committed these changes yet, so let's go ahead and do that before I write anything. Okay, so we've done instance lit. All right, so now if I make any changes, I can revert it. Okay, so I think it's all done besides this weird light bug. I'm not gonna worry about it right now because it's, I don't know, it doesn't really have anything to do with the actual grass system. And now that I think about it, it might not happen in builds. I think I found that out, so. But yeah, there's some weird thing where like light data is being not set correctly. Because you can tell there's like a phantom light above this that's coloring it orange even though I'm moving it. Okay, but anyway, I think what I'm trying to see is if this is all done. Okay, I did this quaternion rotation. Okay, so let's try. Okay. Trying to decide if I want to do. Well, I guess let's do the two extremes, which would be instance lit and fragment lit, and then see if I can what code I can give them that's in common. And then from there we'll do the middle, which are the vertex lit and the hybrid. Okay. So fragment lit HLSL. Okay, and okay, this is actually not right because we do have Teslization. I'll just start with this. Let's see. So, okay, so the biggest difference between the fragment lit and instance lit versions is they have a different structure. Yeah, so which I can change. based on this instance lit property. Yeah, so basically it just has these two other fields tacked on, which determine like, because the sprouting shader has to pass the baked illumination and the shadow mask values to the grass shader, and then but we determine lighting per fragment besides that. Okay, so all right, so what else do I have to do? So yeah, we have the position. I guess the only thing is I have to pass those two values through here as well. So I'll have baked GI and shadow mask, or is it, yeah, shadow mask? Yeah, except it's all one word. So that'll be text chord 5 and 6. So this is the same for tessellation, and then in the interpolators we have to pass a lot more, because basically we have to calculate lighting in the shader now, or in the fragment function now. So we'll have float 2 UV. Actually, yeah, it's a float 3 because we also have we're using texture arrays. Text chord 0. We'll have a position and world space. I'll fix the text chords in a second. Then we've got normal, tangent, baked GI, and shadow mask. Okay, so 1, 2, 3, 4, 5. Okay, so that's all I can think of right now. So this can be the same, except I need to also add the baked GI from the sprout. Okay, so I don't really like this all, like this code being in common, so that would be one thing I'd want to try to combine into one file if I can. And then yeah, this tessellation stuff is kind of all the same. I think the whole function will never change, so it might be worth it if I could pull that in there as well. Anyway, so here, let's see what else. All right, so we got the, oh, I do have to pass, yeah, the tent through here as well. Okay, so yeah, let's just get rid of all this. Have the UV, output, position, world space we've got. Okay, so we don't have the normal yet, but the normal is pretty easy to get. We can, so we basically just rotate by quaternion. Right. Okay, so this is in tangent space. So the tangent space normal is just the positive z-axis. So I would do rotate by quaternion. float 3, 0, 0, 1, Q, and yeah, we'll need to test that to make sure. And then the tangent is the same, except it's the positive x. Okay, and then the bitangent we don't have to pass because we can calculate it from the cross product. What else do I have? Okay, the big GI and the shadow mask are the same for each vertex in the patch, so I can do something like this. Baked GI. And same with the tint, although I think I called it color here. I guess I should keep the naming the same. All right. Okay, and then in the fragment function, okay, still have that, I guess. Okay, so now I basically just need to call that grass lighting file. Or foliage lighting function, I mean. Like we did in instance lit sprouting shader. Okay. Let's just copy this over and see. Okay, make sure I'm editing the fragment lit version. Okay, so the position is now in the input structure. Okay, so the normal. Oh, right. So, okay, we also need to pass the terrain normal through here for diffuse lighting. That's a good point. I think yeah, this actually, okay, no, this is fine. The shape normal is the terrain normal, which needs to be passed to the grass shader. So float 3, terrain normal. Okay, so yeah, I have to pass something else through here, which I think you can have like 12 text chords, so we're fine. Obviously, the more you have, the more your interpolator has to work, but this, the fragment light, we're kind of just going all out, and we'll just see how it all shakes out performance-wise. Okay, so yeah, the mesh normal. Okay, is the normal that's actually passed through. So, oh yeah, we do need to make sure. Okay, so I can, yeah, this fragment that I need to use the, see if I need to flip the normal. Also, I need to read the normal map here. So, okay, let's wait. I guess I can check that in the old shader. Okay, so this is different. Oh, wrong one. Okay, so yeah, in order to get, you can tell if you're rendering the front or the back face of the shader, or of the mesh, with this special argument to the fragment function. And it's nice because that way we can make sure that the normal is pointing like outwards on each side of the mesh instead of like one side pointing the wrong way. So that way we'll get specular highlights on both sides. Okay, well, yeah, we won't worry about the depth normal pass yet. Okay, so yeah, here we'll create tangent to world matrix. Okay, so this is, let's do this. Okay, so here we're sampling the normal map and getting a tangent space normal, and then we transform that to world using this tangent to world matrix. Okay, and then the data sample is we have another texture that lets you vary like smoothness over the grass card. So that's what that is for. Okay, so anyway, now we have this normal vector we can use there, and this is the normal for specular highlights. Then for the shape normal, which is for diffuse lighting, we'll use the terrain normal. Okay, and the shadow chord fragment. Oh yeah, that's because for some shadows you have to have like calculate them in the vertex program because you need to have like a screen space position. Okay, well I guess we should be good about it. Oh, okay, I was smart enough to already put this code here because I knew I'd use it for multiple different shaders. Okay, so what I need to do is the fragment lit function, or fragment lit shader. I also have to pass shadow chord, but only if it requires shadow chord interpolator. Which I guess this is included here. Oh yeah, so in order to get this, I've got to way to do that. Okay, so this tells it to look, because right now we're in this file or this folder, so the two dots tell it to look back into the parent folder, and then we're telling it to look in common for this. So that's what this path is doing. Okay, so if requires vertex, or what was it? Vertex shadow chord interpolator. And yeah, this is basically if you have screen space shadows enabled. Okay, so that's fine. Okay, and now for the albedo and alpha. Got that. Okay, so the smoothness. Let's see here, how do I want to do this? So we take this data sample. I forget what the colors usually. Let's see here. Yeah, I can check the old version, right? Okay, so smoothness is red, specular is green, translucency is alpha. What's blue? Ambient occlusion? Oh yeah, right there. So we'll basically interpolate between the minimum and then 1 based on whatever value is in the texture. Okay, I feel like I didn't fill everything here. Yeah, like I don't have the specular strength. Let's clean this up a little bit and let's make sure I'm not missing anything here. So we got position, view direction, normal, shadow chord. Okay, and I don't have the this position for normalized screen space, which is for the screen space ambient occlusion. Okay, albedo, alpha, specular strength, smoothness. Okay, so I actually have an ambient occlusion minimum value. I wasn't sure if I'd implemented that in this shader. So this does that interpolation basically after the screen space ambient occlusion is applied. Okay, and subsurface, color, thinness. Which I want to multiply by the data sample alpha. Okay, so big GI is passed to us from the sprouting shader because we can't. Yeah, basically, Unity doesn't assign light maps to the grass mesh because it's generated at runtime. So we need to grab it from the from the ground, which is there during edit time. So okay, so ambient strength. Okay, same with shadow mask. Which is for baked shadows. Okay, so vertex lighting and fog coordinate we actually can do. And yeah, that needs to happen in the domain function. Let's see here. Oh yeah, and also this would be text chord 9. Okay, so here, I need to, if this is active, I need to pass it through here. And then we've got Vertex Lighting. I mean, I guess we could actually calculate this in the Vertex program, but okay, actually no, because the Vertex program doesn't know world space position yet. So yeah, that won't work. So output dot fog factor and vertex light. Okay, and then that says pass through. Okay, and then we actually just return this color. Okay, so I think yeah, it's not going to compile or anything because I haven't created the .shader file. But yeah, before I even do that, I need to make the property list. And the reason I want to do it in a separate file is so that we can reuse it for all the different shader passes that this is going to have. Okay, so yeah, we have the color map and the normal map and the data map. Okay, so let's look through, actually this is the old one, and find what other properties I use. I don't think I really do anything until the fragment stage, but okay, so we got the alpha clip already. Oh yeah, so we have a normal strength, I remember. Okay, specular strength, smoothness, ambient occlusion minimum, subsurface color, thinness, scattering strength, and some more things here. Oh yeah, and yeah, the subsurface color is actually a color, so it's a float 3. Okay, so yeah, I think that was it. And finally we can make the shader file. So let's just copy this. Okay, so yeah, I need to have, I guess I should have left the 2 panels open because I'm going to need to make properties for each of the things that appear here. Okay, so let's copy this for the normal map. Okay, I don't know if this works for texture arrays, but I'll just put that there. This helps Unity know that you want to use a normal map in this texture, so it like prompts you if you accidentally apply one that hasn't been tagged that way. Okay, so this is normal strength. I think that will be 0. Also, you can put bump here, and Unity will actually by default give you like the flat normal map color. It's kind of nice. I think for some reason I'll put gray there. Okay, and I guess now we'll do the data texture. Okay, so this will be smoothness, specular, ambient occlusion, and thinness map. So next we've got specular strength. Okay, oh yeah, and this should also, yeah, I forgot to change the label here. Okay, ambient occlusion. I guess this should start at 0. Okay, so this one is a color. And this is basically a tint that you apply to any color that results from subsurface lighting or translucency. So we'll just start it at white. My finger can't find the comma. Oops. And these kind of just like tweak the way that subsurface lighting works, so it's kind of easier to just show that when we finish this up. Okay. Alright, so yeah, we have the forward lit pass, and yeah, it needs a lot of keywords. Basically everything that's here, I think. We got this. Okay, I wanted to make sure this was the forward lit pass for the ground and not the forward lit pass for the sprouting pass, because yeah, that would be slightly different. Okay, so yeah, we've got main light shadows, additional light shadows, SSAO. This is all reflection stuff for 2021. Light maps. Don't know why there's a space there. Yeah, more light map fog. Okay, I think that's it. Oh yeah, the debug stuff. We don't support that yet. It would be nice to. Oh, yeah, but I'm not even working in 2021 right now, so anyway. Okay, and then we take the fragment lit and fragment lit. Okay, did we get a... Okay, there was some error. An instance lit couldn't open lit past common. Oh, I forgot the HLSL. Oh yeah, and I also need to rename the shader. I was wondering why it said it was instance lit. It's because I didn't rename the shader up here, so... Cannot convert from float 3 to float 4. Okay. Oh yeah, right here. This needs to be a float 3. So does that one. Similarly here. Yeah, the shadow mask is supposed to be a float 4 actually. Okay, I changed this to data map. Fog cord and vertex lighting. Okay, did I name it something else? Oh yeah, fog factor and vertex light. Okay, so no errors. So yeah, let's see what warnings. The output value of vertex is not completely initialized. Let's see. So it's saying that this tessellation control point, I don't set something. But why does... I'm surprised it only gives me a warning and not an error. Oh, I don't set the terrain normal, do I? Okay. So we're not quite done because I need to make... Well, if I tried to put this like a grass system, or if I tried to make a grass material that uses fragment lit shader, it wouldn't work because right now our system thinks we're using the instance lit version, so it's using the version of the sprout structure that doesn't have these values, so we're going to get misaligned data for one. And also our sprouting shader doesn't even set these values, so they would be just 0 in the best case. Okay, so I need to fix both of those things. Okay, so first I guess let's you kind of need to just make a copy of this shader, I guess. And oh yeah, so let me think. I don't use this anymore, so I'm gonna get rid of that. It's while I'm here. Okay, this should be like that. Okay, so I'm trying to think. I mean, I guess I kind of have to do it. I was gonna say it'd be nice. Well, let's see. Well, I don't know. I was gonna say I could like use the same shader somehow and like have a toggle, which sort of would work. Because I could have a different pass that's like grass sprouting fragment lit, and it would call it would just set like a different define value, and then I could get rid of these keywords because we don't need them anymore for the sprouting shader. I guess the only problem there is that we'll have all these properties that are just not ever needed. I guess it basically just be these properties. I wonder, is there some way? So I could fix both of these things if I could somehow pull in a pass from another file, but I don't know if that's possible. I don't know if you can include a pass block, because I think hash includes have to be inside this HLSL HLSL program and HLSL. So let me see. So Unity include pass. Okay, so I thought there might have been something. The use pass commands insert a named pass from another shader object. You can use this command to reduce code duplication in shader source files. Okay, so it looks like it uses the shader name. I guess that's fine. Okay, so what I could do then is I mean, I don't really want to have a shader that... It'd be kind of nice if I could just have like a file that just includes passes, and then the two shaders just use the use pass from them. But I think you kind of have to have one shader and then another one just copies it. So you kind of have a base shader. I guess it doesn't really matter that much. I just noticed this version does not compile for instancing, which I think was an oversight on my part. Okay, so I guess what I would do is make a copy of this, and then we would just use all these passes, basically, except for this one, and then we'd have our own. Yeah, so does it really matter which one is the quote main version? And it'll basically have the same properties here, except no lighting stuff. Okay. And I'll just delete all the passes. Okay. So we'll want to use pass. Oh, I just messed it up. So forward lit. Let's see if that throws an error. No, it works. Okay. So we'll use the forward lit. We'll use a shadow caster. Oh, why did I do that? Depth only. Depth normal and meta pass, and also the sprouting depth texture pass, or yeah, depth only. Okay, and then so the only one that we have to redefine is this one. Yeah, Visual Studio doesn't really work with Shader Lab that well. But anyway, okay, so basically this is gonna be the same, except we'll set this to Fragment lit, and okay, so we don't need any of this stuff because we're not gonna calculate any lighting in the shader now, or in this shader. We all do it in the grass shader. Okay. Okay, and then this texture based. Hopefully I can switch between the two just using this define, but we'll see. So first let's copy and paste this. Okay, oops. So it's pretty much the same, except I need to take out all the lighting stuff. So yeah, that stuff. Okay. Yeah, it'd be nice if you could also share properties. I guess I should see if they can. Unity, Shader Lab, share properties. Okay, seems like no, but I'll have to look into that more. Okay, so then in the texture base, okay, so even in the fragment lit version, we still have to get the light map stuff because we can't calculate that. But some things like the fog coordinate and the shadow coordinate we don't have to do. Okay, yeah, this file is a little messy. I should probably clean it up. Okay, so let's see here. We'll need the position, normal, and tangent. We do need the light map. Okay, let's move this like this. Okay, and then these last. Okay, well, the sprout cull we'll always need as well. Do I need the world space position if I'm not doing lighting? Yeah, because we pass it to the culling. Okay. And then I need the normal and tangent to do normal maps. So. Okay, so these we only need so if def or if not defined. I guess I can do it this way. If defined instance lit Okay. All right, let's clean this up a little bit. So if def instance lit. Oop. I meant to press tab there instead of whatever I did. Okay. So what I wanted to do, yeah, there's so much, like this function is way too long. There's so much stuff in it. So what would I have to pass? Like if I wanted to pull this code out, which would be pretty nice, I would need to pass the input structure, the normal, and the sprout structure. Okay, well, that's not that much, so let's go ahead and so it also had the normal, which is just what I calculated from the normal map, right? Yeah. I guess the question is that stored anywhere else? Okay, not really. So yeah, we can pass it. It's not that big a deal. I was just gonna see if it was redundant. Okay. So also, yeah, I should probably wrap this in a instance lit as well, because the foliage lighting data probably won't exist in the fragment lit version. Yeah, in fact, this could probably be pulled out into the common file, but I'll just wait to do that. Okay, so now we got rid of all this, so if instance lit we'll call this, except we'll actually just multiply by it because the tint can also be set by a texture. I don't think we actually handle that yet, do we? So I guess for now we'll just set it to 1. Yeah, so let me write a note. I don't know really where to put it. So sprout color tints from a texture. We could pretty much, well, I don't know. I was gonna say maybe we could just multiply it kind of based on the albedo texture, but then it would be like brown because this is growing on dirt, so I don't know, maybe we need to have an option for that. Okay, so anyway, that's a lot cleaner. We could also, what about pulling out this bit? Yeah, so we can move this to the route past common file. so I have this one. Calculate wind quaternion. Okay, so yeah, I think I actually thought about this before, but the reason I hadn't pulled all this out is because this tangent to world bit is kind of... wait, do we... Oh no, okay, the normal map is there. So I think this code will actually be in common with all the different sprouting versions, but the thing is we just have to pass so much data because we'd have to pass the normal tangent, bitangent, tangent to world. Well, okay, this actually comes out of it, but then the random seed, the bend angle, and then all this stuff for wind, which I guess we could do. And then it would just return the root and the tip, but I don't really know if it would save much. I mean, I guess it would because, like, if for some reason I had to change the order these were called, so I probably will do that, but I don't know, it's not really needed right this moment. Okay, so invalid conditional expression. Let's see here. Oh yeah, this should be if defined. No interpolators. Oh right. Okay. So the interpolator structure doesn't exist here because the interpolator structure is defined after we call this hash include. Which is a bit of a shame because I'm gonna have to pass everything we need independently. Okay, so what do we need? I guess it's this sample GI stuff. Which is again gonna be a pain because if I want to make it a macro, I have to have two different versions of the lighting that one that passes the dynamic light map for 2021 and then one that doesn't. So we also, yeah, this is a terrain normal. And then there's, okay, that's a shadow mask. Okay, how do I want to do this? I'm not sure. Oh, also, yeah, I don't actually return the color, I just realized. So return foliage, or calculate foliage, lighting. Okay, I mean, I guess I could just make a structure that's like baked lighting data. But the thing is, if you make too many of these little structures, you end up making your code like more verbose than you originally had it. But I guess I could use a macro to like transform the input into it. Let's just see. Oh yeah, we also have this shadow chord stuff. And I don't think a macro can call a macro. this isn't really what I wanted. Okay, well, I mean, I think this is fine actually, because we can just... This is a shame because it's like making things a little bit more complicated than they should be. But... Okay, so anyway, we need the terrain normal. Which I guess really isn't baked lighting. So maybe I should rename this. Interpolated lighting data. Okay, so here, this is in the lit pass common. Okay, so it's always just a float 4 no matter what. Float 2, light map, UV, and then the dynamic light map UV. Float 3, vertex, circle harmonic. Oh, that's another thing. Well, no, it's fine. We can just set it to 0. Sorry, I'm just thinking ahead. I'm gonna need like multiple versions of this macro, but we already got that. So, and then the fog coordinate. Okay, so this is good. This is the problem is I can't use this sample GI in a macro. So I kind of have to somehow, but I also can't access this input. And the problem is I can't, the way macros work is they just won't even call this. Like this won't even appear in the code if it's not defined. So I can't like pass these values through a function because in certain versions this dynamic light map UV doesn't even exist. So it'll give me an error. I don't know. I kind of feel like yeah, it's just annoying, but I think I'm gonna have to just have each shader fill this data and then pass it to the lighting function. Which I don't like because this is just gonna be a lot of copied code. But I guess there won't really be any logic to it because it'll just be passing values into here, so whatever. It's a shame, but okay, so it will just pass that. Okay, before I copy it, let me... I don't know, I'm sure lots of programmers have encountered this where like something would just be like so easy and quote beautiful or whatever in programming it, but it just won't work with the way the syntax is. Actually, no, I don't want to do that because I actually want it to tell me if something is missing. Okay. No, I don't want to copy this. I want to copy this. Or not copy, display it. Okay, so we've got shadow cord. Oh yeah, and okay, so some of these, I guess I don't have to pass them anymore, really. I could just pass a shadow mask and the big GI. Now I can just copy this over here. Yeah, unfortunately, still have to have this macro here. Okay, yeah, so we'll pass this. Okay, so this is actually wrong. It should just be calculate lighting, and then I pass the lighting data, the sprout, and then the normal. Which I guess I could just include the blade normal in this structure, so that way it doesn't have to be separate. Okay. Okay, so I was a little confused why I'm rotating by a quaternion there. So do I not actually calculate the blade normal otherwise? It doesn't look like it. So what I want to do is move. Oh, okay. Well, I guess this is fine actually because yeah, we have the quaternion as part of the grass sprout, so yeah, that's fine. This is anything with this input I need to replace because now we use oh yeah, so I don't even have to pass the blade normal because I calculate it in here. So what was the normal vector for? Oh, it was for this. Which should actually be based on the terrain normal anyway. Should fix. So I guess I am fixing it. Okay, yeah, so I'm playing the normal map. Okay, but this is actually the grass growth direction. Let's see here, which is probably different. What about this? This is like a growth tangent and bitangent. It's like not actually the terrain tangent. This is starting to, I'm having like multiple tangent spaces, so it's kind of confusing. So this is the tangent space for the terrain, but then not necessarily the same direction that the grass grows, but then here. So do we actually, so this tangent to world, what does it do? So this creates a tangent to world matrix where the normal is pointing along the growth direction. Or actually I think the bitangent is, but okay, so that's fine. But I don't think I actually need the tangent and bitangent from this. I actually want it tangent to the terrain because I use it to offset, yeah, here. Okay, so now I forget what I was even doing. Let's see. So calculate tangent to world. We'll come back to that. All right, so this is actually, I guess it is calculating tangent to world, but I don't really need these variables because yeah, I just need this. And actually, like, yeah, and see, I rearranged this because I want the normal to be in the y direction along the bitangent. So it's not, yeah, this name isn't good, I don't think. What should I call it? I guess grass orientation. So I guess I still, oh, no, I don't even need to do this anymore. Oh no, I guess I need it for this part. Okay. So, I guess now it can just be a normal function. It doesn't have to have an out parameter. This would be float 4. Get rid of those. Okay. Yeah, so that's fine. Okay, now here we apply a normal map. Where do I? maybe it's in the math. I forget where I actually do that. Okay. So this is fine, except I kind of need the bitangent. I guess I can grab it out of the tangent to world matrix. But I always forget the syntax for that. Let's see. So like, because the way Unity does it is technically the transposed tangent to world, but then it fixes it by multiplying it in the opposite direction. If that makes sense. I'm looking for, yeah, the core render pipeline shader library. And then space transforms. They have create our tangent to world. Okay, yeah, so I don't really want to have to copy this code. So if I don't have to, but so I can just get the bitangent out of the matrix that it returns here. But because it's the second column. Okay, so can I just... I think I can... Okay, I guess I can just do this to get the bitangent. Let's see if that works. But anyway, okay, so the tangent... So the tangent is the first and the bitangent is this second column. Or I guess they're rows. I always get confused in HLSL. Okay, so yeah, the row, it's, I guess, row major. Okay, anyway. Okay, so that's all good. I guess, what was I even trying to do in the first place? Yeah, so the terrain normal. I want to use the normal world space that was perturbed by the normal map. Okay, so we got terrain normal. Yeah, so I don't call this anymore because it's already been dealt with. Okay, I don't need to normalize this because it's been normalized already. Okay, so the shadow chord. Just read that from here. Shadow mass. Did I? Okay, I did. I was gonna make sure that I finished filling in all these values. And then big GI. I don't know why my fingers have so much trouble typing baked GI. Okay, so this is set up finally. I'm sure I've forgotten something because I kind of got on a million different tangents while I was trying to finish this up. Let's see. Float 2 to float 3. So yeah, big GI should be a float 3. And the shadow mask should be a float 4. Okay. Shader warning. Shader is not supported on this GPU. That's not true. Must have just been from the bug. Okay, I just realized I spelled this wrong. Unless, okay, so it's giving me that error. Is this use pass not working? I feel like it would tell me if something isn't correct. Let's just. Okay, maybe. It doesn't like tell me if the pass isn't found, which is kind of annoying. Oh, the pass has to be in all uppercase. Okay. Forward lit. Shadow caster. Depth only. Depth normal. Meta. Grass. Sprout. Depth only. Okay, well. Don't know what that error means. Hopefully we'll be able to figure it out. I feel like, yeah, it's not even showing materials, so I feel like it doesn't like this use pass. What happens if I just comment these out? Okay, that's not a good sign. So anyway, this error was that blade smoothness doesn't exist. Oh yeah, that's actually no, it's not true. I was gonna say it's because maybe it's compiling it in the fragment lit version, but yeah, so we have the correct properties. Oh no, okay. I realize what might be going on. Oh, this is a shame. So the problem is when I can't reuse these shader passes because they include the instance lit file, which doesn't have the same properties, although I don't know, that's probably not the reason that it's giving me that error, but that is going to be a problem because it will have like unneeded values in here. Okay. I really don't want. I really don't like the idea of having to copy and paste all these passes over, but I think it's the only thing I can do. that's so annoying. I just don't like it because if I ever have to change any of these, I'll have to change it for every single shader. And we already know, based on this, that I want to have like 4 different versions. So if I'm going to have one that's for Vertex, or for instance, and Fragment lit versions, then I'll have 8 different versions of these shaders. What can I do to get around it? There's like code generation, but I don't really want to have to do that. Okay, well, I'll just think about it, I guess. But yeah, for now, I'm gonna have to copy everything over. Okay, I guess I can leave that one. Maybe I'll do that idea I had where we have 2 different passes, one for each. But that's still, if we're only ever going to use the fragment lit version, that still leaves like some properties that we don't need. Which, I mean, maybe it doesn't really matter because it's just a few extra fields, but I don't know, I don't really like it. Anyway, so literally the only difference here is I'm including a different file. Okay, so this also says blade smoothness isn't defined. Oh yeah, which is it isn't there, but okay, I see it right here. I'm gonna move this down here just so it's a little bit more. Oh wait, was that the? Oh no, that was the instance lit version. Okay, so yeah, so it's saying the blade smooth doesn't exist in the fragment lit version, which we know that. So wait, why is it even being compiled though? Because instance lit isn't defined. Let's see here. Oh, it won't even show up because it's not like a shader variant. Yeah, so this code shouldn't even run because the instance lit isn't defined, I don't think. Let's just make sure. If defined, if defined. So the only time we define it is in the instance lit shader, which is where it should be. Oh, I also defined it here. Okay, no, I guess not. I mean, but it's not. Okay, so I know what's happening. So now, since I copied that file to create this other version, it got stuck in there. Okay. All right, so there we go. No errors. Why did the... Oh gosh, I'm dropping frames again. I hope I don't disconnect. Okay, looks like I'm good for now. Okay, so anyway, we're almost ready, but still have... So if I did it now, it still wouldn't look correct. Because the C#, well, because C# defines like the size of the grass sprout structure, which we know is different if we're instance lit or not. Oh, by the way, I can delete these. But we don't, like, the C# has no idea what type of material we've set up, so we have to kind of tell it. One other thing I was going to check. Do we ever set the terrain normal? Because yeah, what I should do here is set the terrain normal world space. Okay, and that's actually, yeah, so now I don't even have to include that in that structure, I just realized. Because it's in the sprout structure when it's instance lit, so a little less code duplication is always nice. Oh wait, it's the opposite way. The terrain normal has to be included if in the fragment lit version. Okay, so yeah, gotta go back to how it was. Okay, yeah, and then so if it's instance lit, we do that. If defined fragment lit, we need to actually kind of similar here. We set the shadow mask and the bake GI on the sprout, and then we also need to set the terrain normal. Okay, yeah, I think I'm gonna take that away because yeah, if something is not set, I want it to complain to me about it instead of just silently not erroring. So no terrain normal. Oh yeah, so I forgot to delete that. Oh, also, so this growth direction should be used here instead of the normal. Or it should be used here, actually. Do I want the wind to be based on the grass's direction or the terrain normal? So, yeah, you need the normal because that's how you calculate the turbulence. I guess it should be based on the terrain. So actually, yeah, this should be to the growth direction. Yeah, we need for the orientation. Okay. Anyway. Alright, so on the C# side of things, we've got this grass feature, which handles the extra shader passes, and yeah, it's pretty messy. Definitely in need of some cleanup. So let's see what we can do here. Okay, so we have the instance lit. Is it still correct? Close everything and check. Okay, so we've got position, root quaternion, tip quaternion, dimensions, tint, tessellation factor, texture index. Okay, so that's for the instance lighting. For the fragment lighting, we need all this plus the terrain normal, the baked global illumination. Again, I can't type that. And shadow mask. Okay. Alright, so yeah, you have to tell it the size of the structure, so you basically just count the number of float variables. So we've got 3 plus 4 plus 4 plus 2 plus 4 plus 1 plus 1 plus 3 plus 3 plus 4. Alternatively, I could have just done the instance lighting stride plus these, but I kind of like them being independent. I'll rename this to sprout structure because grass is like the whole system where a single instance is a sprout. Okay. Change this to sprouting pass. Okay. Let's see. Now, I guess, do I want to... Okay. Do I want to rename some of these scripts while I'm at it? Okay, so the camera manager... I think I'm just going to call this the grass manager. So we'll have the grass manager and then the grass feature. Okay. So I guess the question is, do I need to create this here? Let's see, yeah, because this class is the thing that's really messy because it has all these public variables. But it's because I kind of have to... So I update them every frame in case something changes. Would be a easier way to do it. Or a cleaner way anyway. So the buffers are actually created on the grass manager. Which which we actually probably want because it's going to be persistent for the lifetime of the scene, whereas the render feature kind of is not tied to the scene, so oh yeah, pretty messy. All right, so let's see. So obviously this is like pretty much where all the magic happens. First we create the virtual camera projection matrix, which is where, yeah, we basically just make a camera that views downwards to try to find terrain to sprout grass. And then we, using that, okay, so I get culling parameters. Oh yeah, so I get the culling parameters from the visible camera, but then I set it to use oh, I see. Yeah, I set it to use our new projection matrix. And then I get culling planes, and this is so you can cull stuff that's outside the view of the virtual camera. Okay, so then we get a command buffer, and we render the sprout pass, right? Oh no, this actually just sets up the virtual camera. Okay, and yeah, then if we have a depth prepass, we create... Yeah, so these draw settings basically runs culling and figures out everything it needs to draw. So this is for the sprout depth pass. And that's so that, like, if we have stacked terrain, or terrain made up of multiple objects, the grass will only grow on the surface that's closest to the camera. And then this is what actually creates the sprout data. And then we basically reset the camera to match the visible camera so it can continue rendering the rest of the scene. Okay, so first, yeah, it'll probably be a lot cleaner if I just get rid of some of this stuff I was testing, which I don't actually need. So I guess I really don't need to pass all this stuff. Okay, so yeah, this actually needs to change a bit because also if we use per instance lighting, then we can't cast shadows, but So what I kind of want to do is I want to have one C# class that like manages everything. I don't really like it being split between these two, but some things just have to be. So I wonder, what would be the best way to handle it? So maybe, okay, so I think these should go maybe in their own file. Actually, let's just wait a second. I think what I'll do is put all of these in a single folder just for grass stuff. I don't know why it gave me that sound, but no, I want C# script, sprout structures, and yeah, we'll just put the sprout structures in there. Okay. Okay, so this, I mean, this stuff doesn't really need to be passed. The sprout pass can just figure it out itself. Which means all these can be private. So, share tag, filtering settings. I guess that was it. Okay, and then these other ones, I don't really want them to be public, so this configure is actually set or called by Unity or the URP. So we should make something else. Set up routing pass. Oh yeah, should be void. And I'll just pass the data I need to. So we got the buffers, the view matrices. What do? Okay, so yeah, those do change because it's set by the grass manager. I don't know. Maybe I'm not actually helping much. Why do the culling params need to be public? Are they actually ever used? No. Right? Okay. Oh, yeah, that's fine. Okay. Okay, so this is stuff that's basically set every frame. Okay, and I want to change this. Oh, the depth pass is fine. Okay, I was gonna say I want to change the bit that we choose between the fragment and instance lit, but I don't think this render pass even cares really. Maybe when configure is called, or even execute, we'll just grab this data that we need from the grass manager instead of having it like passed to us. So maybe we'll just have a reference to the grass manager. So yeah, let's change this to grass manager. Then the sprout pass, we can set the grass manager. Okay, and yeah, I can do whatever I need to. So that way, all right, so this bit should, okay, so really we don't really have to do it at real time because cache shadows probably won't change at real time, but I don't know. I don't know if it really makes much difference. Okay, let's see. Okay, so let's make an enumeration. Yeah, because I do want to try that hybrid, so it would be different from both of these. Oh, okay. Well, I fixed that there, but probably clean this up a little easier. I don't know, we'll come back to this, but okay. I just wanted to. Oh, we still got another error. This is not. future proof, but also, yeah, we don't do this anymore. Okay, anyway. So instead of this, I would just call the data or get this stuff from the grass manager. Oh, does it actually really help anything to do it like that? Okay. And then indirect arc buffer. Okay, and yeah, here we're resetting it. An indirect argument buffer is where we count how many grass blades there are. Okay, so all this we don't have to set, but at this part we do. But this should really be settings dot type equals fragment lit and cache status is on. Okay, so I think the way I'll do it is the grass manager basically tells us all the data we need to know, but then this system just puts it all together to render it. Okay, so this is like testing, so I'll leave that there. Yeah, oh yeah, I think that's when I thought you had to have 2 passes for the depth. So we could probably clean this up a little more, but it's relatively clean. So yeah, we have culling. I could put the culling in its own function, maybe. Let's just see what this would look like if we extract the method. Okay, I don't know. We'd have to. Yeah, that's kind of messy, so it's fine. It's not like it's that much code. Let's write some comments. So, compute culling and matrix data for the virtual camera. Set up virtual. Sorry, couldn't get to the mute button in time. Set up virtual camera for rendering. Okay, so this executes it. Render depth prepass. Render sprouting pass. Okay, and then reset projection. Wait, or let's the camera matrices for the visible camera. I guess to match the visible camera. Okay, so that makes, I don't know, it's not too messy. I want to change this to temporary grass sprouting target. Although, yeah, we don't really care about this really. Because yeah, this is that texture that's not actually used at all. Okay. So what do I want to change here? Okay. I don't think I actually need that anymore. I think that was for an old system. Okay, do need that one. What is... Okay, so the world size. This is like the size. Oh. Let's change this to basically, yeah, we don't want to have bounds, so should this be late update because it's drawing? I don't think it actually matters, but let's just try it. Check to make sure everything works still. Okay, no, it does not work, but okay, so saying the index buffer is null. Okay, let's not change. I kind of just want to. I don't want to change much logic at this point. But oh, okay, something. Oh, it's probably just because the material got deleted. Yeah. Okay, now it's back to, well, sort of working. Okay, so what I'm looking at, like this texture size and world size is fine, but it doesn't really make it very obvious what they actually do. Basically, the world size is like the max area that will grow blades. So like if I set this to 64, yeah, they're visible farther out. And then the texture size, you can only grow, basically you can only grow one blade per pixel on the texture. So since I doubled the world size, you also need to double the texture size to get the same density. Yeah, I think I've thought about this before. Like I could name these differently, but I might be better just to kind of leave them so people have full control over it. We could also just do a tooltip. I guess width and height. Okay. And then this is like the maximum number of sprouts on screen at the same time. The height from I guess above the manager that the sprout ray casting camera looks down from terrain above this point will not have grass. The close, let's see, I guess people know what a near clip plane is, I guess. ones are relatively obvious. I don't know. Oh. I don't know what's happening here because all I did was change those tooltips. Okay, there we go. Oh well, this should be instance lit, but okay. I'm not sure. I don't know. These names I might change. I guess they're fine. They're kind of like abstract, so it's hard to think of like names that are really just descriptive. Okay, does this need to be like this? Yeah, I don't know why it was. I guess something used it at some point, but. And yeah, we passed the view camera. Okay, so this follow anchor and the LED anchor was what I was wondering about. Okay, so the follow anchor is what. So this is actually dynamically placed, isn't it? How come it... Why is the grass turned green over there? I don't know, this lighting bug. Okay, so the follow anchor, I guess, is what the... Yeah, where the raycasting camera... is centered. But... Okay, so it is set here, but only when we initialize it. So, oh, the reason it's like that, okay, is because we get its position to follow the rotation of the camera, but might be a simpler way to do that, because we could pretty much do the same thing by just taking the camera's forward position and then multiplying it by the radius. Right. That way we wouldn't have to have this random anchor. Let's try that real quick and just see. Okay, so follow position equals camera. What is it? So we view camera forward. Oh, okay. We have to do transform forward times view camera near clip plane plus. So this world size we don't save. I guess. Oh, it's just the settings. Okay. Is there any reason you'd ever want this grass thing to be decoupled from like this follow anchor to be decoupled from the main camera. Or something. Because that would be the only reason why you might want to have the follow anchor be different, but I can't think of why you'd ever want that to happen. Yeah, it's messed up right now, obviously, though. Oh, I forgot to divide this by 2. Okay, so yeah, basically we're doing the exact same thing, except we don't have... I guess I should have left it on local rotation. Except now it's not based on the some random little anchor game object, so it'll make it a little bit easier to set up. So yeah, we can get rid of that. I think this will be better. Okay, and then the other, so the LED anchor. So we let it be different than the camera because... Why, actually? Do I want it to be different than the camera? Should it be the same? Because, let's see. Because right now the LED anchor is the player, so theoretically you could bring the camera away from the player and it would be able to see the LED levels. Wait, what's going on there? Oh, is it maybe because the max sprout is too low? No, because more sprouts. Let's see if I keep on bringing it back. So for some reason the follow anchor is being stuck there. So it works that way.